Hello everyone. In our previous video, we looked at different representations of patterns. So we looked at these visual patterns and related the figure number to the number of elements in the figure, and we found that we could represent this in all sorts of different ways: ordered pairs, tables, mapping sequences, graphs. What we're going to look at today is how to find different parts of those representations, and we're going to attach some labels to them, specifically what are called domain and range. And the easiest way to learn about domain and range is to think about a vending machine. Yes, it's true with Mr. Kelly, everything is in fact food. So let's look at our vending machine, and let's start with these buttons. And because we're getting a mathematical relationship here, I'm going to say that this button is 1, and this button is 2, and this button is 3, and this button is 4. Just to give them some labels, and we know that numbers are useful, so we'll go with that. And then we need to label these. Let's say for a Coke, let's call that C, because that would make sense. For a Coke Zero, let's call that a Z. And for a Diet Coke, we'll call that one a D. And I apologize that Z and D is a little difficult to see. But what I can do now is actually set up a relationship between this, just like we saw before. And I'm going to do this as sort of a mapping type of thing, that if I press button number 1, I get a Coke. Button number 2, I get a Coke. Button number 3, I get a Coke Zero. And button number 4, I get a Diet Coke. And you can see that what I've set up here is pretty much a mapping. There's not much difference between that and the mapping that we looked at before. And so I've built now the relationship between these buttons and what comes out of the vending machine. Well, those have specific names. The buttons that I pressed we call input. And that name kind of makes sense if you think about it there for a second. The input is what I do to the machine, what I'm putting in, hence the input part. And so everything that's over here on the left side of this mapping is input. And then what comes out of the machine we call the output. I feel bad writing on a person's face. So I have the input, 1, 2, 3, 4, and then the output is what happens afterwards, and that in this case would be whatever comes out of the machine. Well, it turns out that since this is just a mapping, I could rewrite this in any other way that I wanted to. I could do this as ordered pairs, 1C, 2C, 3Z, so on and so forth. I could do this as a table. We could have 1C, 2C, 3Z, so on and so forth. I could even do this as a graph, even though it's not clear where this would be. I would just have to kind of make up something there. It would end up being more like a bar graph than our typical line graph that we think of. And we could do this as a sequence as well, C, C, Z, D. But what I want to talk about now is the fact that the inputs always have a certain place that they appear in these representations. And the output always has a certain place that it appears in the representation. And we're going to apply different names to those. The input is what we call the domain, and the output is what we call the range. So the domain, again, is the set of all the input values. So everything we started with. We also tend to call those X values if we don't know specifically what they are. And the range is all the output values, called Y values. And what we're going to do now is we're going to go through and for each representation, locate where the domain, the input values are, and locate where the range, the output values are. So let's start with this one, a set of ordered pairs. And if you think back to how I wrote the example with the vending machine, you'll find that the domain is all the first numbers in our set of ordered pairs. So I'll underline those in blue. So -2 is part of our domain, -1 is part of our domain, 0 is, 1 is, and 2 is. So it's the collection of all those first numbers that is what's called the domain. And here's how I would write that out. There's a particular way. How we communicate this is important because math is, in essence, a language. So what I'll do is I'll say domain and then put a colon. Don't get lazy and just abbreviate this as a D. Write it out as domain. And then I want to make curly brackets. Now these are hard to draw. You can see mine is distinctly not perfect. If you're having trouble thinking of how to draw it, think about drawing a mustache. So sideways mustache, almost looks like a bat too if you turn your head sideways at it. Anyway, domain, colon, and then our curly brackets to show that everything we write afterwards is a set, and then we write down all those numbers separated by commas. And again, the domain is just the set of first numbers, the input, the x values in those coordinates. So there you go, there's your domain. And interestingly enough, if you have a repeat, for instance, if -2 showed up multiple times, you don't have to write it multiple times in the domain. Once it's in there once, we know it could be used multiple times. So now that we've seen the domain, and we said those were all the first numbers, a clever chap might be thinking that the range is where? Well, of course, it's the second number. So the range is the set of all the second numbers, which I've now underlined in red, and we write those out in exactly the same way. My range, colon, curly brackets, and then I list out all the numbers. And again, if there's a repeat, I do not have to list repeats twice. I only have to list them once. And so there you go. My domain is the set of -2, -1, 0, 1, 2. My range is the set of 20, 13, 6, -1, and -8. And notice we know it's a set that these all belong together because of the curly brackets. So there was an ordered pair. Let's now look at what a table is going to look like. And this one's nicely labeled for us, X and Y. Remember that our domain is a collection of all the X values, and our range is a collection of all the Y values. So when we go to write this down, it's pretty simple. For the domain, look down the left side of the table. So the domain in this case, again, don't get lazy, write it out. The domain is -3, -2, -1, 0, and 1. For my range, that's just going to be, again, the collection of Y values. So in this case, -25, -18, -11, -4, and 3. If you're wondering if the order matters on this, the answer is absolutely not. This is just a collection. Think of it like a bag full of numbers. If I'm carrying around a bag full of numbers, it doesn't matter what order they're in. It's just a container with all these numbers in them. So when we're listing domain and range, don't feel like you have to list them in any particular order. Now that being said, I started from the top and went to the bottom because I wanted to make sure I got them all. So you may want to put them in order just to be systematic and make sure you have them all, but you don't have to have them in order. All right, mappings. Mappings, again, are pretty easy. It separates the domain and the range for us quite nicely. The domain, just like on a table, will be all the numbers on the left. And the range, again, just like a table, is all the numbers on the right. So if I go to list the domain, it would be, in this case, 0, 1, and 2 inside the world's worst curly bracket. There you go, you're welcome. And our range is everything in the right oval, 5, 7, and 9. So interestingly, with the mapping, because when we're listing the domain and range, we don't repeat values, excuse me, and we find that in mappings, we don't repeat values either. We just use multiple arrows. So it turns out that in a mapping, everything on the left is already a list of what's in the domain, and everything on the right is already a list of what's in the range. And then we simply have arrows connecting them. Sequences. This is the absolute hardest of all the different ones that we're looking at to get a proper domain and range for it, or at least it's the one students have struggled with the most in the past. And here's why. When we look, there's only one set of numbers, and we want two. We want the domain and the range. So let's talk about the range first, because it's actually a little bit easier. So the range on a sequence is literally just all the numbers in the sequence. So when I go to write them, I would say that the range is going to be 19, 15, 11, and 7. A sequence is just a listing of the range. There's nothing else there. So when I go to find the domain, where is it? Well, it turns out the domain is hidden in the order of the sequence. 19 is first, so the element of the domain that goes with 19 is 1. 15 is second in the sequence, so its domain value is 2. 11 is third, so its domain value is 3, and so on and so forth. So when I go to write the domain, I'm starting at 1, and I have 1, 2, 3, and 4, and that would be my domain. So again, the domain is just the position of each number in the sequence. 19 comes first, so its domain value is 1, so on and so forth. Now, here is the other one that students typically struggle with. We are to find the domain and the range, and when we do this, we have to remember that the domain is the horizontal x-axis, and the range is going to be that vertical y-axis. So let's find the domain first, and what I'm going to do is I'm going to take each one of these points on there, and I'm going to find where that point is if I brought them all to this x number line. So let's look at this one. This one actually is on that x number line, and so its value is -4, and so that's its domain value. Its x coordinate, where it is on there. So our first domain value is -4. Now I'm going to look at this one. Notice I'm going systematically from left to right to make sure I get them. And I look either straight up or down, whichever direction I have to go. In this case, I have to go up to get to that x-axis. And when I get to the x-axis, that value is -2. When I look at this one, I go straight down, in this case, to the x-axis. And the value I get to is 0. And for this one, I look at the value for the x-axis straight up, and it is 1. And so those are my domain values. For my range, I'm going to do the same thing, but instead of moving up or down to get to the x-axis, I'm going to move left or right to get to the y-axis. So I'm going to start from the top and work my way down. This one actually is on the y-axis, and its value on this y number line is 2. So I would say my range is going to be 2 for that one. And then, again, I just go down the list. I see this one, and I'm going to look straight over this way to where it is on this y number line. And this one is at 0. Over here, this is the next one up, so I look to see where it is on the y number line. It's at -1, and this one is at -3. So that's sort of the proper way to think about the domain and range for a graph. There may actually be an easier way for you, though, and I feel like I would be remiss as a teacher if I didn't show you this, because I think it would give you a lot better access to it. We have all these representations because some are easier than others to look at. For example, when we're dealing with these coordinates, ordered pairs are much easier to look at. So if I wrote out the ordered pair for the green point is 0, 2. For the red point, it's -4, 0. For the blue point, it's -2, -1. And for my orange point, it is 1, -3. So if I just go ahead and write the coordinates for each one of those points, it now becomes trivial to get the domain. All I have to do is look at the first numbers, -4, -2, 0, and 1. So by transforming to a different representation, I make my job a little bit easier. Same thing for the range. Look at the range values now. 2, 0, -1, -3. piece of cake. I can read them right off. So whichever method works for you, it is probably faster for most people to transform this and then get the information out of the ordered pairs. But I went through that other process to show you where the idea comes from, because that is important too. Finally, let's look at what happens when I have some repeated values. I'm going to, for this one, use the method of just writing out the coordinates. So this would be at -4, 3. This one is at -2, 3. This one is at -2, -1. And this point is at 0, 0, which is a very special point that we call the origin. So know that name. If I say origin, I just mean the point 0, 0. So it's sort of the starting point for our graph. So when I go to list the domain and range for this, I'll do my domain in blue because I've been doing that the entire time. My domain is just the list of all the first numbers in those coordinates. So in this case, -4, -2, and look at that, -2 appears again. I don't have to write it again. I can just write it once, and 0. So for my 4 ordered pairs, I only have 3 values in the domain. I don't have to write the repeated one twice. Kind of handy, because this is just a list of the numbers that I will use in my domain or in my range. So in my range, I start looking at all the numbers. Starting from the top, I've got a 3, and then I've got another 3. Well, I don't have to write it again. That's good enough. And then I have a 0, and I have a -1. And so we can see from my 4 points, I only have 3 domain and range values, and that's quite okay. We're more than welcome to reuse these.